So that PhET simulator, we went through and we talked about some of the things that can, the concepts that are kind of behind angle launch. I want to go through one problem with you today, and I'll try to kind of break it up so I'm not just going through the problem from start to finish. We'll go through one in-class problems, 2D motion in-class problems, I believe is the title of it, and we're going to look at question number 6. Question number 6. So question number 6 on 2D motion in-class problems. 2D motion in-class problems, yeah. Looks like the tennis ball rolls off the table. Okay, yesterday we did number 5. We're going to look at number 6. So a ball is thrown at some angle. It doesn't tell us the angle. I don't care what the angle is because we don't do the trig functions. It's thrown at some angle. And it has a horizontal velocity of 8 meters per second. And if it lands 12 meters away, what was the initial vertical velocity? So what I'm going to ask you to do for question number 6, I'm going to give you a little bit of time to kind of set this one up, is I want you to go through and work through the green sheet problem types. Is it a 1D or is it 2D? Is it a projectile? Is it a horizontal launch or an angle launch? If it's an angle launch, is it also a delta y is equal to 0 problem? Now, I do want to remind you that in the question number 5, yesterday, assume the arrow lands at the same height in which it was fired. Let's make this assumption unless very specifically told otherwise. So unless I very specifically tell you that they don't start and end at the same location, we're going to go with that they start and end at the same height. It's a delta y is equal to 0. What would that mean? A ball is bounced off the floor and caught 2 meters off the floor. A ball is thrown off of a roof and it falls to the ground 3 meters below. Those would be me very specifically telling you the objects don't start and end at the same height. So for number 6, kind of work through the problem types. Is it 1D or is it 2D? Is it projectile? If it's a 2D, is it a projectile? If it's a projectile, is it a horizontal launch or an angle launch? If it is a angle launch, is it a delta y is equal to 0 problem or not? I'll give you a little bit of time to kind of go through, make your list of variables. I'm not asking you to solve for it at this point. Just kind of make your list of variables as you go. Alright, so my video cut out at some point. But what I had asked you to do is go through question number 6 on the in-class problem and go through and identify parts or problem types and information from it. So I'm using the same color coding that I have, all these. Everything written black was because I identified it to be 2D motion. Everything written in blue, this ball being thrown through the air at some angle, is moving freely through the air in 2 dimensions, therefore it's a projectile, so everything written in blue is because it was a projectile motion. Because it was a projectile, I had to make the choice, is it an angle launch or horizontal launch, and it says it's thrown at some angle, so therefore it's an angle launch. All that really tells me is that this value is not equal to 0. So I couldn't write a 0 there, that's what that said. But because it was an angle launch, we have to then say, is it a delta y is equal to 0 or not? And it doesn't say so, so unless I specifically tell you otherwise, this is a delta y is equal to 0 problem. And because of that, these two are going to be opposites of one another. My final velocity is equal to the opposite of my initial velocity in y direction. The question ultimately being asked is, what is the initial vertical velocity? What's my VIY? It's a different variable than we've solved for. So far, but it's just a different variable to solve for. That's all that really is. If we pull information from the problem, that's kind of the last step of my setting these problems up. is we have meters per second and we have a meters. So it says it has a horizontal velocity of 8 meters per second. Is that my x or y? Horizontal is which one? That's our x. So that's my VIX, which is also my VFX. That's 8 meters per second. And it says it lands 12 meters away. So meters is a displacement, and that's going to tell me it's going to land 12 meters away. So general trends of solving for this is we tend to have to find time first and then solve for what's ultimately being asked. And this is, I'm trying to think, I don't think even with a substitution we could do, I don't think we could do it without solving for time first, even if you were to do some substitutions of 2 equations, 2 unknowns kind of thing. So in the x direction, we do have enough time or enough information to solve for time using equation number 3. So in the x direction, delta x is equal to VIX plus 1/2 AX t squared. But because my AX is equal to 0, that back chunk cancels out, and 12 is equal to 8 times t, where t is going to be 1.5 seconds. Okay, so I had asked you to set it up. I should have probably paused and choose solve for time. I apologize. But I asked you to set up your list of variables. Okay, so hopefully you had everything set up correctly. And if not, is there a question in general that I can answer for the class and say, hey, why did you put this there, or where did that go? So I went ahead and solved for time. This is 1.5 seconds. This is 1.5 seconds. We then just calculate. This is what we're trying to figure out. So there's some choices that you could make on as to which equation you want to use. There's multiples that you could. I'm going to show you something really quick, and I'm going to erase it because I'm guessing given the choice, most people wouldn't do this, but it is an option. Like I said, I'm going to erase this in a second. But you could use equation number 2, because VFY is equal to VIY plus AY times T. And you can say, yeah, but I don't know VIY or VFY. You have 2 unknowns. And the answer is kind of, sort of. But remember, final velocity is equal to the opposite of initial. So we really can rewrite VFY as minus VIY. You could. And then say, well, that's equal to VIY plus AY times T, right? We could just use this, we could do a substitution right there. We could, and then you would move this over and you get negative 2 VIY is equal to AY times T. It's possible. Most people don't choose to do that because it's 2 variables of unknowns. But it is mathematically doable. What we need, most people will choose, is in the y direction, equation number 3. And they choose that. So if my delta y is equal to 0, which it is, we can say VI y times my t, which is 1.5, we've already determined that, plus, oops, I missed something in there, sorry about that. This is VI, let me fix this. My original equation should be delta y is equal to VIY times t, that what I had, plus 1/2, I forgot my 1/2, AT squared. So that's going to be 1/2 times negative 9.8 times 1.5. Then when we set this up, or we solve, I should say. we get 0 is equal to VIY times 1.5 minus 11.025. Do some rearranging, add 11.025 to the other side, divided by 1.5, and we get a final VIY of 7.35 meters per second. Yeah, 7.35. So that's how fast it had to be moving in the, got to move you, sorry camera. So that's how fast things would have to be moving in the Y direction in order for it to land 12 meters away, at whatever angle it was. I didn't tell you the angle because I don't really care what the angle is, because we don't do the trig functions that would go along with it. Now, if you really wanted to, we could do inverse tangent function to determine what that angle is, but it's not what I'm asking for. I do want to show you really quick. Sometimes when we go through and we solve for, like if we were to use equation number 3 to solve for a time at some point, we might get some number, and I'm making this up. But if we were to have some number that was like 0 is equal to 5t minus 10t squared, like it's kind of, sort of, I mean, our numbers wouldn't be this, but delta y is equal to VIT plus 1/2 a t squared. So if the numbers magically worked out to be VI was 5 and 1/2 of a was 10, whatever, I don't care, I'm just making it numbers up. Sometimes people will choose equation number 3 to solve for a time, which is fine, it's perfectly fine. Just mathematically make sure you set it up correctly. If you would have, this is completely unrelated to this problem, just for the record. In a situation like this, ZPP, that's what Mr. Engelbrecht said. It's a ZPP, a zero product property. Yeah, okay, right? So the idea is, because you have a t and a t squared, you factor out, and I guess, well, here, let's make this a little bit different, because you factor out 5t, whatever. 3t, let's make it so it's not, what often we would do is we would factor out a t, right? If we factor out a t in the zero product property, thank you, we have two solutions where t is equal to 0 and 0 is equal to 3 minus 10t. So we actually have two solutions. And you can say, well, how in the world can you have two solutions for time? This is a delta y is equal to 0 problem. At t equals 0, delta y equals 0. Right?
That's what the office was.
Okay. So it's if t is equal to 0 at delta y is equal to 0. But most of the time what we're worried about is we're really worried about this time where my delta y is equal to 0. So the only time you really have to worry about that is in a delta y is equal to 0 problem, and if you were to choose equation number 3 to solve for time. I would suggest, if it's a delta y is equal to 0 problem, because you probably know your VIY and your VFY to be the opposite of, so 10 and minus 10, equation number 2 works a little bit nicer, because then you only get that second time, you only get this time. But it is a mathematical possibility, just so you're aware of that. All right, so time, we're getting close. This is the one sheet that I have for problems for you to work on angled launch problems. One thing we have not addressed yet is we have not addressed what an angled launch problem where delta y does not equal 0 yet. So there are 4 problems on this worksheet that have, it's coming to this one. there's 4 problems that are delta y is equal to 0 problems. 1, 2, 3, and 4. I would hold off. My guess is you aren't going to get to problem number 4 today, and that's fine. I'll give you some class time on this, I promise. Okay? But I want to give you some time to maybe get started. In questions 1, 2, 3, and 4, those are delta y is equal to zeros. For the problems number 1 and number 2, I give you 30 degrees, something, 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 60 degrees, something, something, something. Same arrow, some speeds. If you notice your x and your VIX and VIYs are reversed, they're complementary angles. Where should complementary angles land? Same spot, okay? So that's the only reason I gave you degrees in problem number 1 and problem number 2. Number 3 is for referencing. You're not going to use it in your calculations. But number 1 and number 2 are complements. So for part B, it says how far does the arrow travel? For part B, how far does the arrow travel? And if you notice my answers, they're the same. It's just to show you that mathematically they do work out to be the same distances. That's the intent of that. So we got some time left, not a whole lot of time left, but you probably can get through one, maybe get started on the second before we leave for the day. I'll give you some time. Tomorrow we'll talk about what if a delta y does not equal 0. Mathematically it gets a little more complicated, but we'll deal with it. I'll teach you some methods. So.